Hello guys, so today I'll be attempting an integral from the final round of the 2021 Berkeley Integration B. So for this one, you can immediately notice that you can cancel out the x in the numerator with one of the x's in the denominator. So you can immediately simplify it to this: x plus x squared arctan x plus x cubed plus x to the 4 arctan x. And now, you notice that all of the even powers of x have an arctan x attached to it, while the odd powers don't. So I think we can try to factorize the denominator by grouping in pairs. So it will become something like this. Plus x squared arctan x times 1 plus x squared. And we can simplify that into x 1 plus x arctan x times 1 plus x squared. Now, from the 1 plus x arctan x term, let's change that into this. So 1 plus x arctan x equals, if we factor out the x, 1 on x plus arctan x. Okay, so let's change that into this. So it'll become x squared times 1 plus x squared times 1 on x plus arctan x. So the reason we want to do that is because we don't really want an x in front of the arctan x term. That's because if we differentiate x arctan x, obviously we'll get an arctan term in the derivative. And because we don't actually have a way of obtaining an arctan term on the numerator, that basically means we can't really do a reverse chain rule with the 1 plus x arctan x. So that's why I want to factor the x out. Now, if we consider the derivative of 1 on x plus arctan x, however, we'll get the answer being equal to this. And then if we combine the fractions, we'll get 1 plus x squared minus x squared on x squared 1 plus x squared, which obviously just equals to 1 on x plus on this. Okay, and plus, because we actually have the derivative of 1 on x plus arctan x in the actual integral itself, that being this, right? What we can do basically, because I think this is actually wrong, I actually simplified it wrong. This is equal to this. But what we can do is we can just use the reverse chain rule and change it into ln 1 on x plus arctan x plus c, with the 1 on x plus arctan x in absolute value, and then we're done.